Hi there, welcome to this webinar from Solventure Academy. My name is Sascha de Bakker and today I'm going to guide you through a few of the crucial basics in demand management. Now, before we start, it might be useful for those who don't know us yet to give a very short introduction about who we are. What is our company about? And let's have a little look at that. First of all, we have the original company being Solventure, which is a supply chain planning software implementation company. Now that's a big mouthful, but in essence what we do is we implement supply chain planning software, one that we don't produce ourselves, but never mind. And that comes with a lot of supply chain knowledge and a lot of supply chain process management, of course, apart from the IT aspect of it. Apart from that, there's another business unit in the middle here. It is called Solventure Live. Live stands for Leading Indicator Forecasting Engine. What we achieve with that business unit is creating and implementing highly advanced algorithms to include external data in forecasting algorithms so that we can improve the forecasting on a business cycle level. External indicators that we can include could be things like economical factors, but it could also be things like weather, for instance. So that's what's happening in the Solventure Live business unit. We are creating our own software there and the results are quite amazing. So if you want to know more about that, just go to the site Solventure Live. And then, of course, here completely at my left, we have Solventure Academy. Solventure Academy, when you implement supply chain planning software and do all these change management processes and so on for your customers, after some time, you do acquire a bit of knowledge on supply chain topics in various domains like demand planning, inventory management, supply planning, and so on. And a few years ago, we noticed that there is still a need for many companies to get some better training and some better insight on that. Hence, Solventure Academy, hence me, Sascha de Bakker, being the director and the head trainer of this company. And this webinar, of course, is something that is delivered to you by Solventure Academy. What are the different activities of Solventure Academy apart from these kind of webinars? Let's have a brief look at this. In essence, we have two different parts. We have the public trainings, meaning these are trainings that are open for subscription. We organize them. You can subscribe and you can come to those trainings. One of them is the Accelerator Days, as we call it, a 3-day program where we go basically through the entire domain of sales and operation planning. So we start with product and demand management, we go over inventory management, we go over supply planning, and we end up with executive S&OP. It's a 3-day program, as said before, and actually this webinar is part as a preparation step to those Accelerator Days because, let's be honest, we're going to cover a few basics. Normally, most of you will know them or remember them as soon as I touch them. We don't want to talk about those in the Accelerator Days. We want to go ahead in the Accelerator Days, talk about more advanced stuff and talk about the processes that are putting all those things together. Yes. So you're warmly invited. On the next slide, I will show you when the next session of Accelerator Days is. On top of that, we have the charger sessions. Charger sessions are more meant for the C-level, the executives. They're brief, but they're very strategic by nature, and they are often combined with the Accelerator Days. So if you're interested in that, please surf to our website. Next to that, and that's in essence more the nucleus of what we do, we have the in-company trainings. And the in-company trainings, well, we have the more longer-term programs that are recurring year after year. For instance, the development programs, we have a few running there. You could look at them as internal supply chain academies, which we, together with the customer, design and of course also deliver. If you have more short-term needs of specific training, for instance, on promotion planning or inventory management, or you want to know a little bit more about rough cut capacity planning because you're implementing such a process, well, then you can always come to us and then we will design what we call boost camps together with you. And then, of course, again, deliver those trainings in your company. A last word about what we do. I told you about the Accelerator Days. I told you that this webinar is actually part as a preparation step to those accelerated days, meaning that everyone that will subscribe for those accelerated days is actually supposed to look at these webinars, so we don't need to discuss about a few of those basics anymore during those 3 days. Next upcoming session of 3 days is from 7th to 9th of November in Hotel Steigenberger in Zurich, which of course is in Switzerland. I hope to see you there. We still have a few places left for subscriptions. All right, now let's go to the story of the webinar of today. Demand management. It's a crucial cornerstone in all supply chain planning processes. Why? Because it is the input to the entire cycle. If you look at it, and if you look, for instance, at everything that is involved in the sales and operation planning cycle, but you could just as well say that this is almost everything that is involved in supply chain management, then we can easily see or easily understand that having a good view on what we think or what we expect we will sell to our customers, what we will put in the market, is of vital essence, vital importance to be able to serve as an input for all the other planning processes. If I don't know how much I want to sell, it will be very hard to plan, for instance, my inventory levels. So we believe it's a cornerstone in our supply chain management domain, even though, yes, I know there are methodologies that try to not take forecast into account or as little as possible. Okay, I can understand that, but still you need to have an outlook on the future. And that's actually what demand management, forecasting, and so on is about. And let's look at a few of the crucial basics that are involved in nearly every demand planning process. As said before, probably you know them. On the other hand, it might be good to know that, well, you can always refer back to this and see if you're not missing out on a few of them. They're only basics. There's much more to say about that. You can come to the accelerated days to have some more in-depth discussions on that. But let's at least cover these so that we don't that we don't miss out on that. The first one. That's coming back later. I'm not going to talk about that right now. That's too early, that slide. Who put it in there? Yeah, that's what. First basic number 1, Burrito analysis. Why is it crucial? It's a very simple approach, a very quantitative and simple approach, but it helps us to, in a quick way, have a first pass on trying to make the distinction between the vital few, the few important things in our analysis, compared to the many and less important others. Yes, and that's let it be clear, but that's a way we can create some focus. Yes, because focus, we can't manage everything with the same span of attention. So let's try and create focus on that what matters. For those who never saw it, or those who are still a little bit thinking about what is this guy talking about, Burrito analysis, well, you must have heard about ABC classifications. That's where it comes from. It comes from a Burrito analysis. What we actually do is we take a kind of number like last year's revenue, last year margin, last year volume of every product that we want to put in this analysis, or every product customer combination, things like that. Could be anything, in essence. We can easily compare the percentual contribution of each of those data points to the total. If we have a total revenue of last year, we can easily calculate how much product A, product B, product C, and product D have contributed in a percentage way to that total last year revenue. We can sort them going from top to down, so the biggest contribution first, lowest contributions last. And if we then sort them out and plot them out, we basically get a graph that would look more or less like this. We can look at the first top 20 contributors, or it's more the other way around. We can look at those contributors that together already account for 80%, for instance, of the last year's revenue. Very often we see that that's about 20% of your portfolio. That would be your A class. We can look at the long tail of those that only contribute 5%. combined to that last year revenue, that would be your C class, and everything in between would be your B class. How can that help us? Well, this kind of analysis, it's, as I said, it's a first pass. It's not the end of your analysis. You need a lot more things to know and so on. But at least you can start with it and you can start some discussions. And well, you do the calculations, and as I said, you sort it out, you plot it out on a graph, and you would get something like this, just as we have seen on the slide before. Now, erase that little thing there over there. All right, we can look for the 80%, which probably is 20% or something in that neighborhood of our entire portfolio. That would be our A class. We can look for the last 5%. That would be our C class, so this part, and then everything in between would be that B. The C class is actually also what you sometimes hear, the long tail. Yeah? You have a long tail of products, all very small volume, very small margin. It's a big part of your assortment, but still you have them. And to be honest, you also need to carry them with you in many circumstances. You can't always cut this out, yeah? Even how much we sometimes would like to do that. Now, this is quite a healthy curve, one could say, because if the curve would be like this, or rather if we would not have a curve, what would that mean? It would mean that every product or every product customer combination or whatever have you would have an equal contribution to the total. That may sound very balanced, but on the other hand, it would mean that we have no means whatsoever to create focus and to have some more weight and attention put into the very important ones, and then gradually shift our attention as we go more and more to the right side or the left side, in my case, of this graph. So if you will do your analysis, you end up with something like that, even though you may at first glance think it is balanced. Well, actually, there's no balance at all in your assortment, so you might look into that, what is happening here. It will not happen in real cases, but even so, if it goes too flat, it means that too many things get too much attention at the same time. The other thing is also true. If it is really left lopsided, this kind of graph, so it's really crunching up that vertical axis over there, well, then we have indeed a too long tail. Then it's really time to start cutting part of that tail. And then if we would do the analysis again with a smaller assortment, we would probably end up with something like that anymore. But having it completely skewed in that way really means that, okay, we have a few heavy contributors to the overall. We are carrying a long tail. You're running a lot of risk. That long tail is too long. And here, if one of the big contributors fails, you will lose a lot of your business volume or your margin or things like that. So that's a little bit what we're talking about. It's a quick first scan. It's a quick first pass. There are many reasons why you should not automatically assume that something that is in the C class is not important, nor should you automatically assume that something that is in the A class will remain important or as important forever. But it's a first pass, it's first analysis, it's quick, it's easy, and it can start up the communications and discussions internally in your company. All right, that's Burrito analysis. That was the first crucial basic. Let's get rid of that word. Come on. Yep. Okay. We got rid of all the lines. We get to the second crucial basic. Variability analysis. Why is that crucial? Well, luckily, probably, not all demand behaves the same. So some products will have a more volatile demand. Some customers will order in more volatile patterns. Other ones will be much more stable. Having insight on that, well, I hope you can see it's very crucial in knowing where you need to put your efforts in making it better or capturing the the real demand in the market compared to those that are more stable, for instance, because there you can run much more automatically. I will explain that in a moment, but let me first explain what I mean exactly with variability. and what are some other things that we should take into account in the realms of demand management. Natural variability. Natural variability, well, you may ask yourself, or you may make the statement that some things just behave like they behave because we are part of the world, and the world outside is creating some variability for us. A demand pattern. That's the demand that your product shows in the market. Not a lot you can do about it, it's just the way it is. How can we then have some insight in what the variability actually is? Well, we get to that thing as the average. You have an average demand. And then the other thing that you can look at is that deviation from the average. Yes. So how much does this demand fluctuate around that average? What is it useful for? Well, what we try to achieve with forecasting is we want to get as close to that graph as possible. We can try and forecast the average, of course, but probably we want to get closer to that graph. We want to know the ups and the downs. Yes, the closer we can get, the more we are actually forecasting that variability, which in essence is becoming less variable, you could say, which allows us way better to plan ahead for it. If you know that you will have some upturn here, you know that you will need to build up some inventory or plan some extra capacity. That's what we actually try to achieve with the forecasting part. So that's what we do. However, you have to take into account forecasting is an art in itself, which comes with some quantitative methods and also some human knowledge, of course, and it may also go entirely wrong. And if it goes wrong, we're actually inserting extra variability into our system compared to the original variability that was there in the market. This may seem a little bit futile, perhaps, or unrealistic or theoretical, but I can tell you that in many companies, this is exactly what is happening. We are creating more variability through our processes or the non-optimal approach in our processes than what we should prepare for if we look at the actual numbers in the actual market, in the actual behavior. For those who don't know this standard deviation and average thing yet, or not really, this is what we call the normal distribution and standard deviation. What we actually can see is that if we have all the observations of our demand in the past, what we can say is this would be that average, that mean. Yeah? But then we also want to have an indication on, well, I have that mean, but how far does the maximum and the minimum demand fluctuate around that mean? Yes, and that's actually what we can then calculate and is being called a standard deviation. And when we plot it all out, all those observations and standard deviations and so on, we get something like this graph. Yes. Now, the height of the average compared with the width of the standard deviation actually gives us a very good indication on how that ratio is. How is my standard deviation? How heavy does it weigh on my average? Let me try and visualize that a little bit. Here we are looking at a bigger average with the same standard deviation. So let's assume this is 100. Well, this may be 120 or 150. I don't want to continue on that. But it has the same deviation. What that actually means, and I'm going to show that later also, is that it means that for the same standard deviation, if we compare it to the mean, it clearly shows that this timeline is way more variable than this one, because the ratio between deviation and average is smaller here than that. Yes. Let me take the reverse example. In the reverse example, we have the same mean, but we have in the blue line a bigger standard deviation for the same mean. Again, if we would compare the standard deviation on the mean, then you can see that this one, the blue line now, is much more variable than the orange one. So it's really the ratio about the height and the width, the breadth of the graph here that can tell us how variable our demand is. I'm gonna take this over. And that calculation, I already yeah, put it on the table a few times, is what we call the coefficient of variation. Yes, coefficient of variation is a very good mean to compare the variability of one time series against another, regardless of the mean itself, and actually also regardless of the standard deviation itself, not the absolute numbers, but just the ratio between both. Okay. If ever you hear about it, that's what it is about. Now, how can that help us, or what does it tell us actually? Let us start again with that average here, and let us draw a nice line. Yes. And let us draw another line. Both have the same average, or at least that's what I try to depict here. Both have the same average, but clearly the red one is less variable than the blue line. If we would look at it, this standard deviation will be way bigger than this standard deviation. Yes, so the coefficient of variation of the red one will be way lower than the coefficient of variation of the blue one. Yes, important to understand, important to take along in some of the analyses that we want to do, and come back later. Other things that we can do is, or other ways of looking at the variability or the behavior of our demand, is what we call the demand patterns. Yeah, and demand patterns are not only looking at that standard deviation, but they are also looking at, for instance, the number of zeros that you may have in your history. Zeros highly impact all your planning processes in many ways, but we'll come back on that during the accelerator days. We can also look at life cycles, things that are new, things that are dying, and so on. They can also help us in segmenting actually our entire portfolio. All right, I'm going to speed up a little bit because otherwise we will never make it in this hour. Do it like that, do it like that. Come on, yes, thank you. Crucial basic number 3, quadrant analysis. Quadrant analysis, what is it and why is it crucial? Well, we have seen in Burrito analysis that we could look at, say, who is more important in my portfolio than someone else, or than something else. So what are the A products, what are the B products? It's actually a scale of importance that we could call that. We can combine that with that variability that we just looked at. Yes, so maybe there are very important items that are very variable. Maybe there are other important items that are very stable, and so on and so on and so on. So we can come to a kind of matrix, a kind of segmentation, kind of classification on 2 axes. Here it is a 9-cell, can also be a quadrant, so 4 cells. But in essence, what we do is we have an importance and we have a variability. Oh, what did I do there? No, that's the wrong one. Huh? We don't do that. Oh no, these are just 2 Paretos that I have combined. Sorry for that. Sorry for the confusion. So that can also be helpful to have a more detailed segmentation. But apart from that, we can also, as I was already going there, we can also map importance against variability, for instance, and that can help us a lot in trying to find out where can I apply a lot of mathematics to help me create already a baseline forecast, and where will I need way more collaboration, way more qualitative aspects to be able to manage the demand in the future. As stated before, we have an importance level, A, B, C. Well, that would be the A, of course. High volume, high margin, whatever you choose, A, B, C. If you have a kind of variability, low coefficient of variance, high coefficient of variation. If you look at the bottom part, well, in essence, we can say, let mathematics do the trick for you, yes, or already give you a first pass. Whether it's low volume or high volume, probably some of the statistical methods can really help you out already a long way to try and forecast for those products or product customer combinations. Could be both. These guys They're a little bit of pain in the why? Because they are important. They have a big contribution to the overall volume and so on, but they have a high variability. So in essence, they can hit us anytime. And when they hit us, we still want to try and serve it because they are so important. This is where you need your collaborative processes. This is where you put your sales guys into motion to try and talk with the customer or whatever and see what they can do about it. If not, you really need to prepare yourself for this. But you don't just want to blindly put safety stock for these guys because it will explode your inventory levels, for instance. Could be one of the things. These guys, low volume, low importance, but high variability. Each and every one of them will be very hard to forecast in many ways. What you could do is try combine them, for instance, in product groups and try to forecast on product group and then work with postponement strategies. Postponement strategies like make to order, assemble to order, those kind of things, so that at least you don't need to put all those finished goods in your inventory, because again, even though the volumes are small with the high variabilities and the big number, you will end up putting way too many safety stock in your warehouses. Sometimes you can't escape it, and then you just have to take the hits. But try and look at these guys. You can't manage them all, but try and look at these guys and try to get rid of them as much as possible. Is an advice that we give in many occasions. Now, what can it tell us? If you look at the spread, yeah, we do this mapping and we make this a scatter plot basically. And if we look at the spread of variability compared to importance, what we in essence see is something that will be distributed more or less. It's dirty what I'm doing here, I know, more or less like this. We will see something like that, which is quite safe. There will be a few there. As I said before, those are the dangerous ones. Why? When they hit, they can really disrupt your supply chain. So you really need to put people on that with their nose on top of it so that they can manage it. You can't do this with mathematics alone. Here, let mathematics do as much as possible for you. But of course, these are still important. If your salespeople or whoever in the know knows something about that customer is going to leave us or stuff like that, please make sure that you're not just trusting the statistical forecast there, but that you're also getting that information of your sales force or whoever is involved, because they are so important for your supply chain that you cannot miss out on it when they would disappear or when it would shift and change and so on. And these are those little buggers, sorry for my use of words, that you really should try and manage on a more aggregated way, because trying to manage each and every individual of that will be very hard to do. We will just ask way too much effort for what it's worth in total. Yes. Just a few basics. I know it can become way more complicated, but those are a few of the basics already. Basic number 4, decomposition. Now, what is decomposition? I will explain it in a moment, but we saw, and why is it important? We saw these variabilities in our demand patterns, and actually up until now I only spoke about trying to compare the average with how much the real demand is fluctuating around that average. However, that is not really enough. There are a few things in your time series that we can take out of it, that we can detect. And if we can take that out, then we can already have a better view of what is really in that time series, apart from just the average and standard deviation, which are still very vital analyses, or very useful ways to look at it. But still, you need to know that there are other things around the corner. And what can those be? Now, let's look at it. We have things we call level, trend, seasonality, cycle, and noise. That's all that can be in your time series. And how does that look like, or how should we look at it? Well, the level, in essence, is telling us it's level. So it's telling us whether it's a low, medium, or high demand. Yes? Actually, it's just giving the magnitude of the demand. Let's look at it like that. The trend is something else. The trend, many of us know that word, of course. The trend will tell us if over time your demand is going up, or over time, your demand is going down. Yes. So that compared with a level can tell us if it's a big demand going down, or if it's a low demand going up, or a low demand going down, those kind of things. Yes. Seasonality, very well known to most of us, but let's just visualize it a little bit. Imagine we have 2 years. Imagine this is your summer period, this is your summer period. If I have a summer peak in my demand, chances are big that next time I have a summer peak in my demand. Again, I hope you can see my graph. That's seasonality. We can apply the one on top of the other, and then we get a high demand with a high trend with a summer seasonal peak on it. For instance, yes, if we would just measure this with a mean and a standard deviation, it would probably be a very highly variable time series. However, if we know all those different parts, then it's way easier to forecast, although they would jump into that high volume, high variability quadrant, of which I said that it's very hard to forecast with mathematical approaches. Well, if you apply these little fellows, then that would not be that hard as all. We'll look at it in a moment. Cycle is something that takes a little bit more time. This is your business cycle or your economic cycle. Yes, it may be that you just see that over the last 2 years we were going up, but we expect to go down for a few years and then go up again. These are your business cycles. This is something macroeconomical that is coming to you. Macroeconomical indicators, yes, indeed. Forecasting these cycles is what we try or what we achieve with leading indicator forecasting live, Solventure Live, as introduced before. Because also there we could have a temporary trend with a, so the trend overall may go up, but you might still be affected by the business cycles. Level will be what it is it a high or a low volume demand? But in any case, also on top of this, your little seasonal peaks will still apply. So assembling all that together can be very useful. Trying to understand the different parts in your demand is certainly useful. Now, what would noise be or randomness be? Well, very easily. That's everything that is left over, because there will be things that are not easily explained by a level, a trend, a seasonality, or even a business cycle. It's just, or not even the fact that it's a Monday or a Friday. It's just yesterday we sold more than the day before that. We don't really know why. Of course, these are basics. There are ways in trying to get much more grips on that, but for the basics, this is already a start to look at those things. Hope this helps. To visualize it once more, this is a time series. We can detect a trend in it. There's apparently a very strong seasonality in it. Everything that remains, there's the randomness, there's the noise. That will be very hard to forecast. That's basically something that we will try to then forecast with an average. Yes, and that's also the variability that remains. That's a real variability. This is not a real variability. Okay. Basic or crucial basic number 5. Statistical forecasting. Let's look at a few of those statistical methods that can help you. I'm not gonna give you formulas. I'm not gonna try and give some statistical lecture here. I'm just gonna try and see if I can already give you a few of those basic elements in statistical forecasting so that you can start and look up a few things for yourself or start discussing with a few other people a few things. But let's just go through this. And then during the accelerated days, we will look at a few other things on that topic. I'm not going to bother you there with statistical algorithms, but we may include some very, very interesting discussions on that. Okay. But let's use the power of mathematics wherever applicable, or let's at least give the mathematics a chance to create what we call that baseline forecast. First one, the naive forecast. I'll take another color here. Naive forecast. Naive forecast is very naive. It's a very simple approach, but it's used many times, and I'll come back to that later. But the naive forecast, in essence, says, What will happen tomorrow is what will happen yesterday or today. What will happen today is what happened yesterday. Something like that. It's just, I don't know anything, so I just take what I have seen as a last observation, and that will become my forecast. My last observation becomes my forecast. So if this was my last observation over here, and I need to forecast for this period, then this would be my forecast. If this would be my observation in that period, and I try to create a forecast for the next period, that would be my forecast, and so on and so on. That would be my forecast. Basically, I'm replicating my observations with a one period offset. That's a naive forecast. There are a few other, let's say, approaches in naive forecasting, but let's just assume that this is the most naive you could ever have. Well, this is, what happens tomorrow is what happened yesterday. So I'm just going to offset everything, and that is what I will work with. Yeah, may seem completely useless. However, it has more power than one would recognize at first sight. That's a naive one. Let's look at the next one. Because it seems so utterly useless, and because it really follows the up and downs and the up and downs of your pattern, very often we will hear that we want to smooth it out a little bit. Yes, we don't want to absorb all that randomness, absorb all that ups and downs in our forecasting process. So we're gonna level it out a little bit. We're gonna smooth it, and one of the ways we can do that is by using a moving average. Yes. Now let's assume we use a 4-month or 4-period moving average. Then we would take this observation, this observation, this observation, this observation. If then I would create a forecast for the next period, well, I think it's quite safe to assume it would be somewhere around here. Maybe mathematically not entirely correct, but that's what I'm looking at. And so on and so on and so on. If now I would propagate that, I would not get that very nervous forecast, but probably it would go a little bit like that. It will drag along my last observations, but will level them out a little bit by means of an average. And that's what we can call a smoothing factor. Now, what I did was I treated all observations equal. Whether it were 4 or whether I would have taken 6 or 12, it would just have leveled it out. Clearly, one could argue that maybe I want my last observations to put in more weight on the scale than my previous or older observations. Yes? We would have something we call a weighted moving average. For instance, this one will account for 70% of my forecast. This will weigh in for 20%. This one will weigh in for 10%, and this one for 5%. Yeah, probably my ratios are not entirely correct, but I think you can catch the concept behind it. This is more important than that one. So if I would create a forecast, it would not end up here, but it would probably end up, this one is also a bit more important, so that one is really less important. So let's say we will probably end up somewhere over there, a weighted average. Yes, that's a concept. Now, instead of creating a weighted moving average, we can also step into the exponential smoothing algorithms. And let's start with the simple exponential smoothing algorithm. And in essence, it is doing the same thing. It is putting more or less weight on the more recent observations and then creates a forecast. So I'm already showing the forecast to you. No, the forecast is already there. I didn't want to draw this or whatever, but this is basically the same time series, the same demand, and I have created 2 single exponential smoothing time series based on that, but 2 different ones, as you can see. Now, what's the difference between both of them? The difference is the setting of my parameter being the alpha. Very often it's alpha, might be that it gets another letter in some literature. I don't really care, but the alpha. And the alpha will be between 0 and 1. Yes, and that's a smoothing factor. And what does that mean? Well, what you see here are 2 lines with 2 different alphas. The top alpha is 0.25 and the bottom alpha is 0.75. Yes. Yeah, Sasha, whatever value you give to it. Well, the bottom one, what it actually does, the more the alpha approaches to 1, the more weight it will put on the last observation. Yes, it will actually make a mix of the last observation and the last forecast that I already made. So it's even so that if I would put alpha to 1, my exponential smoothing would behave exactly the same way as the naive forecast. Yes. So the more it goes to 1, the more it will take the more recent observations into account, the more nervous it will react on the changes in my demand. While the lower I set my alpha, the more smoothing I will have, the more I will also drag along everything that happened in the past. It's actually also like the more it approaches 1, the more it's a moving average of 1 or 2 or 3 observations, the more it approaches 0, the more it's a moving average of 12, 13, 14, 15 observations, something like that. That's actually single exponential smoothing. If you ever hear about that, that's what they're talking about. Basic methods. Moving average, we saw that it only gives you a level. Simple exponential smoothing, we saw that it only gives you a level forecast. Yes. We can extend this kind of methods with an additional factor, because we were only looking at that level, but we saw before with the decomposition that there's also something like trend or seasonality. Well, there are statistical methods that can take that into account as well. Again, with a kind of smoothing factor, a beta or a gamma. And the first one would be the Holtz method, the trend method, which can not only put some weight on recent observations or things like that, but which can also create a kind of forecast that will go up or that will go down. And if then we add on top of it some seasonality, then we get to the Winters method. We need to add an extra parameter over there, and then we can not only go up and down and give some weight at the last or most recent observations, but we can also put some weight on seasonality factors and then forecast ups and downs for winter summer periods, things like that. Those are the really basic methods, statistical methods that you should be able to find in every statistical forecasting software package, or you can even find that in Excel. These days, of course, we already got way more advanced than just these 3 simple methods, but having a kind of understanding of what this is about, I think, is crucial before you can start talking about all those other advanced methods. Almost there. Basic or crucial basic number 6, accuracy metrics. Forecast accuracy metrics. Now, why are they crucial and why are they basic? Well, if you try to improve your demand planning or demand management process or your forecasts, so to speak, it might be useful to have an idea on how this is going. Yes, I hope that makes sense to everyone. Now, there's a lot of accuracy metrics out there, and very often we hear this kind of thing like, oh, we have an, I don't know, a maybe or a forecast accuracy of 75%. All right, very nice, but do you actually all know what that means? And is that sufficient to really measure your forecasting process? Well, let's look at a few of the crucials we need to take along before we can start those discussions even. A few forecasting error metrics, and you can see we have divided them in 4 blocks. Here we see a error measurement. So we want to compare our forecast with the actuals. That's what we always want to do. We forecasted something, and then we went into that period, we completed the period, and we actually sold something, hopefully, and then we can compare how much, sorry for that, how much we expected to sell compared to what we actually sold. So that's, of course, the basic of forecast accuracy metrics. And here we have arranged them a little bit like, here we compare units. How many units was I off? Yes, how far away in units was my forecast from my actuals? That's first. Of course, we can also make that a relative or a percentage error. So how much percentage does that represent? Was I 20% off or was I 30% off? Those are the kind of things that we can also calculate very easily. And how do we call them? This would be the mean error. Yeah. if we would well, actually this would be the absolute error, this would be the error, and here we would have an absolute error, and this would be the percentage error, and that would be the absolute percentage error. Absolute is when we take out the sign. So here, if we subtract forecast from actuals, we might get something negative. It might be -10 because I forecasted more than I sold. Here, that minus disappears. And if we then would start accumulating all of them, adding them up over time or on an aggregation level, then we could calculate something like a mean again. And then we get a mean error or a mean percentage error, a mean absolute error, or a maybe the most notorious forecast accuracy metric in the world, I think, mean absolute percentage error, where in the top part, the pluses and the minuses cancel each other out. Now, you don't always want that, but if we accumulate that in a percentage error, we can actually get an idea of the overall direction of our forecasting error. The absolute error, they will give us way more idea of the total discrepancy over time between my forecasting and my actuals. Yes, it will really give us an idea of the magnitude of the problem. Combining both of them is actually something that you want to do. You want to have something that gives you an indication of the magnitude, how big is my total forecasting error, yes, but also something about the direction and what direction is this going to. So, because maybe I have a maybe that is near to that is or an MP that is the other way around. Sorry, maybe I have two same maybes of 10%, but maybe one MP is showing 0 and the other one is also showing 10%. Now, what would that mean? That in the first case, I have some deviations. Yes, I have some errors, but overall, I'm looking in the right direction. Sometimes I have some more, sometimes I have a little bit less. That's maybe not so bad. You can plan for that. While the other one is really telling me if I have a 10% maybe and a 10% mean percentage error, then I'm basically looking at I'm over forecasting all of the time. And if I'm over forecasting all of the time, then maybe I can adjust it because I just know that I'm being way too enthusiastic about my portfolio, things like that. Okay. The last thing I want to say about metrics, or last thing I will say about metrics, we have looked at standard deviation. Standard deviation is basically looking at the variability of a timeline or time series compared to its mean. If you want to compare a forecast with a demand in the same way, then you would look at what we call the root mean squared error. Root mean squared error would basically give us an indication of the surface area over here. And what is it useful for? Well, because it is comparable to a standard deviation, it can, for instance, be used to look whether our forecasting is doing better than the natural variability. Remember that one, the natural variability occurring in my time series. Another thing it could be used for is, for instance, for safety stock calculations, but then be sure that you're forecasting better than the variability that's already in your time series. Another important thing we need to take into account when looking at demand management or forecast accuracy metrics, sorry for that, is we need to have a good understanding of the fact that when I create forecast in December, blind forecast, I create a forecast for January, for February, March, and April. Actually, one could say that's a M+1 forecast for January, M+2 for February, M+3 for March, 4 for April, and so on. Yes. Now, if I want to see how well am I doing month over month for the last 6 months, I need to be sure that I'm always comparing apples with apples and pears with pears. So if I want to have a 6-month rolling, maybe, for instance, I want to have the average over 6 months, make sure that you're not taking these, well, let's say 4 months, but that you are taking a lag 1, lag 2, lag 3, depends how far ahead you want to try and forecast. But let's assume you want to be able to forecast 2 months ahead because that's the lead time that you need to take into account. Then this would be the combined archive This would be the series, the time series that you would use to then compare your forecast, to calculate your forecast accuracy. If this is not entirely clear, I absolutely do understand that. No worries. Come to the accelerator days, and there we will go way more in depth on this little thingy here, because it's quite important. It's very often forgotten. Very often companies are just only looking at that M+1 kind of forecast and then think they are performing very well, but that's not always the case. Last crucial basic, and then it's time for some Q&A. We still have time left. Beyond the math, I've shown 6 approaches of analysis, quantitative analysis, some statistical forecast methods, and so on. Those are all mathematics that we can and should apply where appropriate in our demand planning process. But there are things that the numbers just can't tell us. Yes, that they have a sound basis. We should use the power of Excel, of software, or whatever. Why? For the mere reason that I'd rather let the computer calculate stuff than try to find out myself. It's so that they can make so many calculations in the nick of time. Let's use that power, of course. But there are only stupid calculations, stupid algorithms. They cannot know everything. Yes. Let's look at this example, for instance. It might be that we put something over here, but that we know that it's with life cycle management or whatever, or with some marketing action, that soon we will try to put it there, and maybe it might end up there, but then we can still have some discussions with the customer. There's no software you want to rely on to make this happen for you automatically, and just take that for granted. That's one thing, for instance. Another thing, yes, it's gone. Another thing that we need is all those different inputs. There's so much out there. There's your sales forecast. What are they working on? Your customer, what is he working on? And what kind of forecast does he give to you? It's also a very important one. There's budget and target compared to forecast. Are we working for budget here, or are we working for a real forecast? Do we want to include a target? Now, how would you include a target when you're just using statistical forecasting methods? It will not apply just like that. You will need to get those inputs and discuss the discrepancies and the differences with your team. Demand planner inputs, yes, yeah, but I know that sales guy is just always over forecasting, and even though my statistical forecast is not really showing better numbers, I'm not gonna take this for granted, or at least start having that discussion with that person, and so on and so on and so on. There's a lot of things out there that we should try and collect in a collaborative process to finally come to a kind of forecast that will be used by everyone in the company. On the different levels of planning, yes, different levels of planning can also mean that we have different kind of forecasts. If you want to look out at the strategic level or the next year budget, for instance, the detail that we want to forecast on is probably entirely different than the detail that we need on a day-to-day basis. But mind you, whatever you're talking about there, euros, markets, or whichever thing you choose, in the end, it will be units, SKUs, and maybe even locations or customers that you want to be able to produce for. So if you want to go to your production planning, your supply planning, I hate to break the news to you, your inventory planning, I hate to break the news to you, but there comes a moment that we cannot just look at a dollarized budget anymore as a forecast, or yes, I will just have 1,000 units in that product group. No, in that product group I have 10 SKUs. Tell me what I need to do, 100 each, or is there a different kind of split over there? And that's where we need to end up with demand management. Whichever the timeline, whichever the levels are, whichever the different inputs are, whichever the methods are, statistical, collaborative, or whatever, we need to end up with an outlook that can help us on the operational level to plan our week-to-week, day-to-day processes. That's demand management for you. It's all part of a bigger scheme. It's not just about creating a forecast, and we need to try and get that away common, you know. Yeah, it's all part of this bigger process: sales and operation planning, supply chain management, whichever way you want to call it. We can do without, but it will be very hard. The better we get this, the better we can plan for the other things. So installing this, working on that, I think is vital for running your business. Just a few basics. There's a lot more to tell about this. There's a lot more to do with this. There's a big domain over there that we can discuss about during the accelerator days or any other moment you want. But this is where I'm going to end it from my side today, at least with this kind of these kind of slides, with this content. What I hope to get now is a few questions from your side. It's time for some good old-fashioned Q&A. If all is well, you can see a kind of chat box somewhere on your screen. If you have some questions, fire them away. I'll wait for a minute or two, and then my dear assistant will then see if we can get some valuable questions there, on which I will try to respond, of course. Go ahead.
First question, do you have any input on about the alpha, beta, and so on parameters, what they need to be?
I like that one. Yes. So the question was, for those who maybe didn't hear my assistant here, do you have some inputs on what the alphas, the betas, and the gammas need to be? I started giggling a little bit about that because it's a question we very often get. Yes. Yeah, but a good software or a good consultancy project should tell us the exact values of the alphas, the betas, and the gammas. I hate to break the news to you, but that's not how it works. You do have certain approaches that try to find the optimal alpha, beta, and gamma for a certain time series. But that's just a matter of overfitting, because it can only look at the past, just like every statistical method. It can only look at the past and then see what, by coincidence, what combination of alpha, betas, and gammas gave the lowest error. Yes. And then next time it will try and do that again. What you and you get into a case of overfitting. The things you need to take into account when you look at that is, how nervous do I want my next forecast to be? How fast do I want it to react on my on the latest things? With the advantages it can have, but also the disadvantages. And I'm going to give a very fast example. Imagine this is your time series, your trend, your time series that you observe. If you have a forecasting algorithm with a low trend, or with no trend, it will not follow this, of course. It will be way too late. It will always lag. But with a trend factor, you may make it approach this line, and at a certain moment, it will get there. Yeah, the speed to which it approaches that line, yeah, would be your beta factor. Now, you need to take into account this probably doesn't last forever. So maybe you want to get there as soon as possible, but that means that you have a very strong beta over there. If you go like that, then suddenly, then you need to take into account that that beta and so on will define how fast you will be able to catch up again. Yes. So with all advantages, there's also the disadvantage. The stronger I let it add a trend to it, the stronger it will remain. So it really may take some time to catch it up again. So you always need to pay attention over there. The best thing is to classify it a little bit, to segment a little bit, and to monitor it closely, to have a few algorithms with a high alpha, a few with a low alpha, and then put those, for instance, in competition and see if you can then find out which one you want to apply for a certain customer product combination or things like that. We can talk a long time about that with many examples, but that's actually the thing that I can tell you right now. Hope it helps a little bit. Any other questions?
Yes. How do you decide the level on which we should forecast? And by level, they mean product level, category level, etc.
Yes. In the end, it needs to go down to product level or product location level. Yeah, let's be clear on that. However, there is of course this thing, like I can have a product like that and another product like that and a product like that and a product like that. If I would be able to forecast on category level, well, that category time series is probably way less variable therefore, because the pluses and the minuses cancel each other out normally, so therefore it will help me a lot more to, for instance, detect trends or things like that. And that's actually 100% true. That's also something that we stand for. You start at the lowest, maybe have a higher one and a higher one, but as I said before, mind you, in the end, it all needs to come down on that lowest level again. Having a good intermediate aggregation level or a good aggregation level to forecast on, there are a few rules of thumb that can help you there. It will take me a little bit too long here to explain them. But what I advise most of the time is, if it does make sense to you from an attribute and knowledge level, like, okay, we have a product, and the products are basically organized per market, and the markets are then organized per region, if that's more or less the way you work. Well, if that makes sense to you, then probably it makes sense to your forecasting process. Apart from that, we can do a lot of analysis and up and down and scenarios and another pass and another pass and another pass to find the ultimate aggregation level, to find some more forecast accuracy in the end. That's true. But again, mind you, in the end, it all needs to come down on that lowest level. And that's the most important one. And that's not so easy. So there's no one answer there, but we can help you with that if you want to. Hope that helps. I'm not giving clear answers to the people, but I'm just trying to open the different approaches there, the different things you need to talk about, think about, sorry. Do we have time goes fast when you're having fun. Well, I had a lot of fun, of course. Next webinar on inventory and supply management will be on, and I need to look a little bit, September 26th, same time, same channel. I hope to see you there again. I hope you enjoyed it as much as I did. And of course, I hope to see a lot of you or of your colleagues or other people in your network on the accelerated days in Switzerland or on any other occasion. Have a nice day and hope to see you later.